Good morning, student. This is economics class. Still, we traveling in the third lesson. Name of the lesson is production analysis. Dear student, I was finished the last class with the topic called external economics of scale, and this is coming under economics of scale, page number 62 and subheading number 3.6. I want to start the class just to review the class from this slide itself. Economics of scale, here we discussed about the profitness of the industry, and the scale of production is an important factor affecting the cost of productions. But the producer of all want to get more profit. So the production activity of the firm is influenced by the economics of scale. So the economics of scale is classified into internal economics and external economics. The last class we discussed about the both internal economics and external economics. Okay. So internal economics means the advantage are some privileges existing inside of the firm. With the help of these privileges, the firm can able to functioning well and earn more profit. They are also discussed under the fourth topic called technical economics, financial economics, managerial economics, and labor economics, marketing economics, last one economics of survival. Okay. Next is the external economics of scale. This is we discussed about, actually under this heading we discussed about the advantages existing outside of the firm, and with the help of the advantages how the firm can perform. So they are also discussed under four headings. They are increased transport facility, that is the things which are supporting from the outside of the firm for well functioning of the industry. They are called increased transport facilities, banking facilities, development of township, development of information and communications are coming under, that is discussed under the external economics of scale. Okay. Next, diseconomics of scale. This is something disadvantages or unfavorable situation existing outside the firm, which is not really helping the firm to functioning well and doing the business activities without any disturbance. So these are the discussed under the diseconomics of scale. Actually, this is the class starting from this slide. Okay, this diseconomics of scale is the scale of disadvantages of the firm or an industry or an organization. That necessarily increases the cost of production of the commodity or service. That is, due to the diseconomics of scale, the cost of production of the firm automatically will increase. So once the cost will increase, the firm will incur loss. Okay. Further, it will delay the speed of supply. Due to the diseconomics of scale, further it will delay the speed of the supply of the product to the markets. So these diseconomics are of two types. They are internal diseconomics of scale and external diseconomics of scale. Okay, students, let me discuss about the internal economics of scales. When the scale of production increases beyond optimum limits of the firm, what will happen? Definitely the efficiency of the firm may come down. Of course, some of the firm are trying to get more profits. For that, they are pushing the production unit to produce more. So they are extending their after the optimum capacity of the firm. So once they reaching and working beyond their optimum capacity of the firm, definitely they will face lot of problems. This is called internal diseconomics of scale, which is existing inside of the firm. Okay. Next one is the external disaggregations of scale. The term external disaggregations of scale refer to the threat or disturbance to a firm or an industry from factor lying outside it. Okay, this is something, some unfavorable situation existing around the factory or in firm, which will not help the firm to functioning well without any disturbance. Of course, for example, it is strike, always strike. For example, bus strike prevent the easy and correct entry of the worker into a firm. If the firm not getting or enrolled by the workers in time, so definitely the unit produced by the firm will be reduced. Similarly, the rent of a firm increases very much if new economic unit are established in the locality. That is, if there is any new industry will emerge or existing or newly established nearby the existing one industry, this is also will affect the progress of the existing one industries. These are discussed under the that is external diseconomics of scale. Okay, my dear student, next we skip on to the subheading isoquant. Page number 63 in your book, point number, that is subheading number 3.8. Okay. Production function may involve at a time the use of more than one variable inputs. Of course, production function is the functional relationship between input and output. This is also you know very well. The input in the sense, what are the input we are used to do for the production of goods and service, material and immaterial inputs. Okay. So among the inputs, at least one input in particular time is kept in variable or changing, depends upon the scale of productions. Okay. This is presented with the help of isoquant curve. That is, the isoquant will explain. For example, the two words iso and quant are derived from the Greek language meaning equal and quantity. Iso means equal, quant means quantity, respectively. In our presentation, only two factors we take into use for explaining the isoquant production process. They are called labor and capital. Okay. In economics, an isoquant is a curve drawn by joining the combinations of changing the quantities of two or more input which give the same level of output. Isoquants are similar to indifference curve. Of course, this is similar to the indifference curve. So an isoquant curve can be defined as the locus of points representative various combination of the two inputs, capital and labor, lying the same outputs. That is, with the different combination of labor and capital, but they can give or they will give the equal level of output, whatever the ratio of capital labor change, but the output ratio is always same. This is actually discussed under the isoquant, even though if you are changing the factors of inputs. The isoquant is also called equal product curve. Equal product curve or the product indifference curve. The product indifference curve. Okay. Definitions of isoquant. Okay, student, I continue the lesson. This is definitions of isoquant. According to Ferguson, an isoquant is a curve showing all possible combination of input physically capable of producing a given level of output. Okay, here the author is trying to explain If you changing the combination of or the number of inputs, actually in our subject they are taking two factors of production, namely labor and capitals. Among these two, the number of labor or the unit of capital may be changing in a particular ratio, but the output, the result of the output is same. What is the amount of what is the set of the amount of labor and capital previously and now? Okay. அதாவது உற்பத்தியில் பயன்படுத்தப்படுகின்ற the labor and capital அந்த எண்ணிக்கையில் லேபர் எண்ணிக்கை ப்ளஸ் கேபிட்டலுடைய யூனிட் ரேஷியோ சேஞ்சஸ் பண்ணும்போது ஸோ டிஃப்ரெண்ட் சேஞ்சஸ் இருக்கும். பேஜ் நம்பர் 64 பார்த்தீங்கன்னா தெரியும் உங்களுக்கு. there is a table 3.1 பேஜ் நம்பர் 64 combination A, B, C, D and E அப்படின்னு இருக்கு. ஸோ யூனிட் ஆஃப் லேபர் அண்ட் யூனிட் ஆஃப் கேபிட்டல்ஸ் அவுட்புட் ஆஃப் வாட் எவர் இட் இஸ் அது கிளாத்துன்னு புக்கில் கொடுத்துருக்காங்க. ஓகே, நமக்கு அவுட்புட் மட்டும் மீனிங் தெரிஞ்சால் போதும் ஆக்சுவலாக. ஓகேங்களா? ஸோ இங்கே பார்த்தீங்கன்னு சொன்னால் there are 5 set of combinations are there. The 5 set of combination of both labor and capital. But though there is a different set which will give same level of output. This is called a isoquant curve. Isoquant curve. Okay. Let us suppose that there are two factors, namely labor and capital. An isoquant schedule show the different combination of these two inputs that laid the same level of output. It is given below. Okay, this is actually exactly in the page number 64 in your book. Okay, it is seen from the table, actually 3.2. This is exiting the book. That is the 5 combinations of labor unit and the unit of capital laid the same level of output, that is 4 meters of cloth they producing. Okay. So isoquant are based on the following assumption. First one is it assumed that only 2 factors are used to produce a commodity. It is assumed that only 2 factors are used to produce a commodity. Second one, factors of production can be divided into small parts, division of labor. Okay. Techniques of production is constant. There is no changes in the production techniques. And the substitution between the 2 factors is technically possible. That is, if the number of labor was they are trying to increase, okay, out of understanding they will reduce the number of capital in the form. Okay, so this is actually discussed under the substitution between 2 factors is technically possible. That is poor combination of what is the poor combination of what happened? The variable proportion trying to rather than fixed proportions. That is, the production possible function is of variable proportion type of rather than fixed proportions. Okay. So the substitution between the 2 factors is technically possible. That is, production function is of variable proportions types rather than fixed proportion. Under the given technique, factors of production can be used with maximum efficiency. These are the assumptions of isoquant. Based on the assumptions, the isoquant curve is explained. An equal product curve represents all those combination of two inputs which are capable of producing the same level of output. An ISO product curve can be drawn with the help of the isoquant schedule. So this is called isoquant curve. Here in y-axis capital is measured and here x-axis actually, and x-axis labor is measured. So this is the combination of the different factors of production will produce the same level of output. Dear student, see the combinations. There are 5 combinations are there. This is the level of varying labor units and level of varying capital units, but the result, the output is same. It is whatever the ratio of the capital labor, but they produce same level of outputs. Isoquant map. So this is the isoquant map. Okay, an isoquant map has different isoquant curve representing the different combination of factors of production yielding a different level of outputs. So 1, 2, 3, 4 like this. In simple term, an isoquant map is a family of isoquants. Of course, every one isoquant is having its own characteristics. In other words, if more than one isoquant is drawn in a diagram, it is called isoquant map. Isoquant map. Okay. Properties of isoquant curve. The isoquant curve has negative slope. First one is the isoquant curve has negatively sloped. So this is actually next second one, there is convex to the origin. Third one, non-intersection of isoquant curve. Fourth one, an upper isoquant curve represents a high level of outputs. Last one, that is isoquant curve does not touch either x-axis or y-axis. So this is actually suitable for indifference curve also. Okay. Okay, my dear students, this is the properties of isoquant curve. Okay, now we are going to discuss one by one. That is, first one is the negatively sloped. The isoquant curve has negatively sloped. It is sloped downward from left to right, indicating that the factors are substitutable. That is, the factors, if the producer want to increase capital, okay, they must give up the unit of labors, or they want to increase the unit of labor, they must ready to give up the unit of capitals. This is called factor substituting. If more of one factor is used, maybe labor or capital, less of the other factor is needed for producing the same level of output. In the diagram, the combinations A refers to more of capital Ks and less of laborer L2 as the producer moves to B, C and D, more labor and less capital are used. This is actually the diagram. This will help you to understand how the factors of production is changed. Combination A, this is here the producer used 5 unit of capital and just 2 unit of labors. Likewise, he changing the factors of production in the fifth, that is point D. Okay. Next one is the convex to the origin. This explains the concept of diminishing marginal rate of technical substitution, that is MRTS, L and K. That is L stands for labor, K stands for capital. Marginal rate of technical substitution, MRTS. For example, the capital substituted by 1 unit of labor goes on decreasing when moved from top to bottom. So, this is a diminishing convex to the origin. So, this is also one type of the convex to the origin. This is actually explained with the help of the diminishing marginal rate of technical substitution. Okay. If so, it is called diminishing MRTS. That is, it is dependent on nature of isoquant curve. This means that factors of production are substitutable to each other and a capital substituted per. Actually, this is the diagram. Okay, this is diminishing MRTS, constant MRTS, that is marginal rate of technical substitution, and increasing marginal rate of technical substitutions. Okay. Third one is non-intersection of isoquant curve. Actually, so this is the diagram which is helping to understand the non-intersection of isoquant curve. Here there are two isoquant curves showing intersect point A and B and C. Actually, this is not happen. This is not in practice. Okay. For instance, point A lies on the isoquant, that is isoquant 1 and isoquant 2. Here, actually, this is, see this point. But the point C shows a higher output, and the point B here shows a lower level of output. But okay, point C is representing higher level of output, that is 300 units, and the point B shows the lower output, that is called 100 units of output produced. Okay, but here the point lies on both the curve, that is A. If A is equal to C, so nothing but A is equal to B, of course that it is assumed C is equal to B. How it is possible? But by naturally, what happened? B is greater than, sorry, C is greater than B. Okay, so this is illogical. This is not logical. Okay, so that's why at any cost, no two isoquant line intersect like this. An upper isoquant curve represent a high level of output. So this is this one the lower level of output. Red line, this is the shows the high level of output. So here isoquant shows the higher outputs and lower isoquant shows lower output. For upper isoquant curve implies the use of more factors than the lower isoquant curve. Last one is, that is isoquant curve does not touch either x axis or y axis. This is most similar to the what? Indifference curve. So this is not happen. No isoquant curve to touch the either y axis or x axis. Okay. This is actually explanation for the, but this is the properties of isoquant curve. Okay. Okay, my dear students. So this with that I conclude the lesson and continue the lesson from the next video. Okay.